You were standing on a hillside in Colorado in 1882 watching a small locomotive negotiate a switchback on a narrow gauge railroad climbing into the mountains. The track is 3 feet wide between the rails, perhaps 2/3 the width of the standard gauge main line you saw yesterday on the plains. The locomotive itself is small enough that 2 men could almost push it, and it is hauling a string of equally small cars loaded with silver ore. The line clings to the side of a canyon you would have considered impassable, climbing grades that no standard gauge railroad could have managed. This is the story of how a generation of American railroad builders, faced with mountains that mainline engineering could not conquer, deliberately built smaller railroads, and how those narrow gauge lines opened the mineral wealth of the Rocky Mountains before the standard gauge could reach it. The narrow gauge movement began in the 1870s, drawing inspiration from successful small gauge railways in Wales and India. The argument for it was straightforward. A narrower track required less grading, smaller bridges, tighter curves and lighter locomotives. The construction cost per mile was roughly half that of standard gauge, and the resulting line could be threaded through terrain that a standard gauge survey would have rejected as impossible. For a mining region where the freight was high value and the geography was vertical, those economics were decisive. The Denver and Rio Grande, chartered in 1870 by William Jackson Palmer, was the most ambitious of the American narrow gauge projects. Palmer's plan was to build a 3-foot gauge network reaching from Denver south to Mexico and west into the silver country of the San Juan Mountains. By the early 1880s, his railroad had crossed the Continental Divide twice, reached the silver camps at Silverton and Leadville, and built itself a reputation as the most spectacular piece of mountain railroading in the United States. Records from the period document grades of 4% and curves of 24 degrees, numbers that no standard gauge engineer would have accepted. The narrow gauge had problems the main line did not. Freight arriving at a gauge break had to be transshipped, car by car, from one set of equipment to another. Locomotives were too small to handle the tonnages that the mines were beginning to produce. The lines could not carry standard gauge rolling stock from connecting railroads, and the connecting railroads could not carry narrow gauge cars without dual gauge track or expensive car hoists. By the 1890s, as the silver economy matured and traffic grew, those limitations were costing the narrow gauges more than the construction savings had once gained them. The conversion to standard gauge began in the 1890s and continued for half a century. The Denver and Rio Grande converted its main lines first, leaving the most rugged branches on 3-foot gauge, because the cost of widening them was prohibitive and the traffic on them was declining anyway. The Colorado and Southern, the Rio Grande Southern, and the smaller Silver Region lines followed similar paths, converting where they could and abandoning where they could not. By the 1950s, the narrow gauge in the American Mountain West had shrunk to a handful of branches operated mostly for nostalgia and for the lumber and livestock traffic that still required them. The last common carrier narrow gauge operations in the lower 48 states ended in the 1960s. A few segments survived as tourist railroads, most notably the Durango and Silverton in Colorado, which still operates the original Denver and Rio Grande track to the silver camps it was built to serve. The narrow gauge did not become the standard, and it did not survive as a practical freight network. But it gave the American Mountain West something it had needed at a particular moment in its history. A way to build a railroad into country where a normal railroad could not have gone.